Hello friends, welcome back to my channel Chemistry with DB. So in this video, I'm going to explain stereoisomerism as it occurs in the transition metal complex ions. Now we all know that stereoisomerism is shown by molecules which have the same molecular formula and same structural formula, but a different arrangement of atoms in space. The spatial arrangement is different. And so far we had learned that for geometric isomerism, especially a type of stereoisomerism, a double bond is essential. However, transition metal complexes also the groups cannot rotate, and therefore this gives rise to geometric isomerism as well as optical isomerism, and we are going to discuss that in this video. So these are the two types of stereoisomers, geometric and optical. Now we are going to see how these occur in the transition metal complex ions. Now first we'll discuss the geometric. In square planar complexes, cis-platin is a very important chemotherapy drug, and in this platinum is has got two ammonia ligands and two chloride ligands. So what happens is that if the two chloride ligands are on the same side, this gives rise to a cis-platin, and if the two chloride ligands are on the opposite sides here, then in that case this gives rise to a trans-platin. So that is the so what we see here is that in square planar complexes also we can see geometric isomerism when it's a transition metal complex is involved. Now the second example I'm taking is when it's an octahedral complex. That means the coordination number is 6, but it has got two different types of ligands. So in this particular complex you can see that there are 4 ammonia ligands, and there are 2 water ligands. So when that sort of a situation arises that there are 2 different types of ligands, then in that case, if the ligands which are 2 in number, if these happen to be on the same side like this next to each other, then it's going to be a cis. However, if these 2 ligands, water ligands, are on opposite sides, then that will give rise to a trans. Okay, so this is how geometric isomerism can happen in a situation when there are 2 different types of ligands. One, there is 4 of these, and the other one 2. Now let's come to the optical isomerism. Optical isomers, are isomers which are non-superimposable mirror images of each other. In octahedral complexes also we can see optical isomerism happening when there are 2 different types of ligands. So I'm taking exactly the same example as the previous one, as copper with 4 ammonia and 2 water ligands. In that case, we have already discussed that this is the cis isomer when water ligands are next to each other. If the water ligands being next to each other, however, in a just a mirror image of the cis isomer. So this is a mirror image of the cis, that gives rise to a optical isomer of this cis. Got it? So that is the optical isomerism happening. So therefore, if you are ever asked a question as to draw 3 isomers or 3 stereoisomers of this kind of a complex, then in that case you can just go ahead and draw a cis isomer as we did in the previous example, and then you do an optical isomer of the cis, and that will get you to the correct answer. Now let's see what happens when you have an optical isomerism happening in octahedral complexes with bidentate ligands. For example, if we have ethyl diamine or ethane dioate, so those are the 2 bidentate ligands, and we can see that it's a bidentate ligand because nitrogen has got 2 nitrogens and these have 2 lone pairs, and both of these lone pairs can be used to form coordinate bonds with the cobalt ion. And in this one we see that it's in this position, this one bidentate ligand has joined, and other one can be a mirror image of this one, so we can draw it like this. So that is one example. Next example I'm taking of optical isomerism happening in a cobalt complex with ethane dioate, which are also the bidentate ligands. So you can see that here in this one, oxygen has got the negative charge and lone pair. So therefore, these oxygens can be used to donate lone pairs to the cobalt. Now, so again in the exactly in the same way, and then we can do O minus here, O minus here, and then the C double bond O, C double bond O, like this. And in this one, it would be O minus here, O minus here, bonded to C double bond O, C double bond O, like this, and then O minus, and then C double bond O, C double bond O. So we have clearly seen here that we can see optical isomerism happening in cobalt complexes with ethane dioate, wherein three bidentate ligands are there, and then we can draw the mirror images of each other, and those will be the enantiomers of each other. I hope you liked this video, and if you did, then please like, share, and subscribe. Thanks for watching this, and I look forward to see you on my next video. Bye. Take care.